Problem. Here's the problem. I have 4 unspecified constants. Yes, C1, C2, C3, C4. I should only have 1 unspecified constant with relation to x because it's a first order equation, and 1 unspecified constant with relation to y because it's a first order equation. I have too many unspecified constants. I have 4 and I have to get it down to 2. So question is, how are we going to do that? And the answer is use the original equations. So again, this is too many unspecified constants. Too many unspecified constants, and that earns me a frowny face. I do not like that. That is sad. We can go back to our original differential equations and get to 2 unspecified constants. So originally, we had, before we rearranged, x prime equals x minus 2y, y prime equals 2x minus 3y. You can use either of these. I'm gonna go with the first one. So I also know that x prime from the solution that I came up with, sorry, today is an awful lot of arrows. From the solution I came up with, I know that x prime is negative 3c3 e to the negative t plus c4 e to the negative t minus c4t e to the negative t. Right? Just taking a derivative from my solution, I can do that. And I know that this has to be equal to x minus 2y from my first equation up here. You could just as easily use the second equation. It is up to you. Either one will work, not a problem. So let's plug in and see if we can find our unspecified constants. Here's what we've got then. We are going to have, and this is going to be with equating coefficients. We are going to have, one more time, x prime equals x minus 2y. Yes, x prime, I've lost my original problem. X prime equals x minus 2y. So c3, negative c3, e to the negative t, plus c4, e to the negative t, minus c4t, e to the negative t, equals c3 e to the negative t plus c4t e to the negative t minus 2 c1 e to the negative t plus c2t e to the negative t. Plugging into that original equation, If we equate coefficients, look at the pieces that we have. We've got e to the negative t pieces, and we've got t e to the negative t pieces. So we have both e to the negative t and t e to the negative t pieces. So we can look at coefficients and make sure they match up. This gives me a negative c3 plus c4 equals c3 minus 2c1. Seeing it? Matching up those coefficients, right? Negative c3 plus c4 equals c3 minus 2c1. For my t pieces, negative c4 equals C4, I think I probably screwed something up because someone's asking a question. What did I do? You see what I did there? Oh, good, I didn't screw it up. Negative C4 equals C4 minus 2C2. I'm matching up both of those. And I'm trying to get to 2 constants. So let's solve this first equation for C1. C1 equals negative 1/2 times negative 2C3 plus C4. Yes, yes, if I take the C3 over to the other side and divide by negative 2, or we can say C3 minus 1/2 C4. Yes, C1 equals C3 minus 1/2 C4. Same thing, we can solve for C2. So C2 equals negative 1/2 times negative 2 C4, or just C4. So C2 just equals C4. Those two happen to be equal. Okay, 18 slides later, final answer. Here's where we're at. X equals C3 e to the negative t plus C4 t e to the negative t. That's from before. Y equals, I don't want C1 anymore. I want stuff in terms of C3 and C4. So C3 minus 1/2 C4 e to the negative t, because that's my C1, right? I solved for C1. Plus, I don't want C2 anymore. I said that C2 was equal to C4. So we've got C4 t e to the negative t. And this, if I can box this using semi-straight lines, chalkboard is so much better, is an answer with just 2 unknown constants, which is good because that's the maximum number that I am allowed to have. Okay, deep breath. I told you today was a lot of prep. Today is a lot of prep. How are we doing? Deep breath. Questions at this point in time. I just walked you through a lot. I'll pop my screen up back in just a second. But how are we doing at this point in time? Decent? Decent? Yes? Decent-ish? Does the connection to algebraic equations help you understand what's going on here? It's the same process of elimination, right? We're just playing a little bit fast and loose with derivative notation. That's kind of what's happening. Good-ish? Yes? Okay. I would like to make this more general and a little bit cleaner so that we don't have to go through, what do I multiply by the first equation? What do I multiply by the second equation? What do I subtract, etc. So let's see if we can make this just a little bit cleaner and come up with a slightly more precise, even less feeling our way through it way of doing